this problem we have to identify in terms of pairs. We have to describe two correspondences, right? The correspondences are given by these equations, right? Every pair of natural numbers satisfying these equations is part of the correspondence. So let's begin with the first, the R, okay? To identify that, what we're going to do is to eliminate y here, okay? Y is 16 minus 2x. And remember, both x and y are natural numbers. So what we do now to identify the pairs is we start giving numbers to x until we exhaust all possibilities here. So first we take 1 for x, and if we put 1 here, then you have 14. Okay, then you put 2, then you have 12, then 3, and then you have 10. Then you put here 4, and then you have 8, 5, and 6, 6 and 4, 7 and 2, and the next one would be 8, but then for 8 you have 0, and 0 is no longer a natural number, and for the rest of the x, higher x, you get negative numbers. Neither of them is a natural number, so this is it. This is the list of all possible pairs. The domain of R is, of course, the set 1, 2, 3, 4, 5, 6, and 7, and the range of R is equal to 2, 4, 6, 8, 10, 12, and 14. All right? Well, for B, in B you have to do the same for this other correspondence, and you do exactly the same thing. Just eliminate y as a function of x, so you have 25 minus 3x, and again both are natural numbers, so you do the same thing. You start giving numbers to x until you exhaust all possibilities. So here's a 1 first, and then you have 22, then you have 2, okay, and then you have 19, then you have 3, and then you have 16, 4, and 13, and 5, and 10, 6, and 7, 7, and 4, 8, and 1, and of course if you put here a 9, 3 times 9 is 27, 27 is larger than 25, so y is going to be negative, so from then on it's going to be negative, so this is it. These are all possible pairs in S. The domain of S is the set of 1, 2, 3, 4, 5, 6, 7, and 8, and the range of S is equal to 1, 4, 7, 10, 13, 16, 19, and 22. That's it.